Meeting recording started.
AIKO, Redefine Solar for Carbon-Free Society. Welcome to AIKO online training series. This is the AIKO PV Modus ABC Technology lesson. I'm Federico Brunelli. I'm Solution Europe Director at AIKO. AIKO has been founded in 2009 and introduced into the market different new technology that impacted on the PV industry. In particular, in 2021, we patented the ABC cells, all back contact cells, with an module efficiency of 24%, available in Europe since 2023. The ABC cells are available in ABC modules provided by AIKO for residential, C&I, and utility. For the residential are available the full black modules and also the white modules, with the full black available in dual glass monofacial cells. The C&I are available as a dual glass monofacial and backsheet. The utility are available as a dual glass bifacial. Let's see the main features of the ABC modules by AIKO. These are the higher power output, partial shading optimization, high temperature restriction, better temperature coefficient on the Pmax, and the higher bifaciality rate. Let's discuss for each one. Let's see on this video the advantage of ABC cells. Let's see that all the area of the cells is available to generate energy. And you see here the average improvement in power compared with the average in the market. So we have 30 watt more for residential and 50 for C&I and utility. These are thanks to the advanced technology, the improvement on several aspects of the cells that make the cells more performance. If we compare the performance of AIKO cells, for instance, according to the module efficiency, we see that the AIKO is the world's highest commercial efficiency module with more than 24%. We can see after there are other competitors achieving also, let's say, one achieving more than 24, others achieving 23, but let's say that in general the market is oriented to 22.5. So this is a high quality and high performance PV modules. If you're curious about the technology used by different manufacturers, you can see the N-type is dominating as a wafer technology, and also back contact are the PV modules that are providing more high efficiency. And another very interesting feature of AIKO is the behavior of the modules under shading. In this test, we are going to show the comparison between on the left, ABC modules by AIKO and a traditional TOPCon. Every PV module is connected to a water pump and also a water jet on the background that show you the performance. Here is important to see the difference in voltage as we are covering the PV cells. So ABC modules by AIKO starting from more than 45, the traditional TOPCon 41, and now the test starting with a shading of two cells. And you see that the AIKO dropped very little to 22.7. The TOPCon dropped already under 30 volt. And the next is with 4 cells covered. AIKO is even again more than 40 volt. And the TOPCon, as you can see here, the 13.8. Also, we see that the characteristic cells covered by the shadow are very say characteristic because they cover one of the substring of the PV module. So we have in this case with the 6 cells covered, we have 35 from AIKO, 0.3 for the TOPCon, and now the last is with 12 covered. So we have a strip that covers these 12 cells, and we see AIKO is again 29, so very good performance, and the traditional TOPCon 0.2. We have also a rapport test from TubeNord confirming that with covering a single cell, we have a more performance, a higher performance of 30%. In this slide, the concept about the principle about the partial shading optimization is explained. As you can note here, the difference when we have a covered cells, the difference is that in the ABC modus, the bypass diode is not activated. That is something that happened with the traditional model. So also we can very quickly get the value of 30% and figure out how it works. This is the reason under this, the technical reason under this is the low breakdown voltage of the PV cells by AIKO, the ABC cells, that is lower than the others. So when shading occurs, the cells we can say that are switched off. So let's say that the bypass diode is not activated, so we have more performance, and also for the reliability of the PV modules is also much better because the diode is not stressed, so also is more long lasting. Concerning the behavior of the PV modules and the shading, we have also another important characteristics, that is the temperature of the PV cells after 1 hour in shading. We see here the comparison, and it goes first the traditional model with 147. So this is a TOPCon with 147, and let's see AIKO, the ABC AIKO, that is also N-type, but you see that we stop at 100. Also, this is very important for the reliability of the modules. Obviously, the very high temperature, something like 150, have an impact on the durability of the PV cells. And also remember the less stress on the backsheet, for instance, in case of a glass backsheet module. So more performance and also more durability. The temperature coefficient is another important parameter considered by PV designer, installers design the system. The definition of temperature coefficient is, in this case, is on the Pmax, so on the power, is the drop in power, decrease in power as the temperature of the PV cells increase. So when we see in the data sheet the value of Pmax of the power, maximum power. This is the data calculated as a standard testing condition, that for the temperature of the cell is 25 degrees Celsius. So when we have a PV cell's temperature higher than 25 degrees Celsius, we have a drop in the nominal power of 0.26%. Here we have a comparison between TOPCon with a value of 0.29% Celsius degrees, so let's say a good quality TOPCon, and ABC in orange. And we see that when the temperature of the PV cells is 60 degrees Celsius, we have 1.5% more performance. Okay. If your question is when we achieve this value of PV cells temperature is something like when the environmental temperature is between 30 and 35 degrees Celsius. So let's start also to analyze the value. This is the importance of this value. According to the datasheet, we can have say an higher power, something like 7%. So when the temperature is of the cells is 60 degrees, we have an additional 1.4%. Okay. So you see here how it is important to have a higher power modus, but also how it is important to save the power in different situations. Concerning the bifaciality rate is the potential of the rear of the module compared to the front. For AIKO PV cells, this is available in utility, and here we see the improvement in the nominal power in different conditions. Of course, it depends from your project, from the location, and for other parameters, but we can provide some general data that you can see is around 5%. So we saw the topic before roughly 1.5%, in this case 5%. So you see how it is important that the improvement in the performance bring more power and also then more productivity. If we consider the technology we have also of the PV cells, is also very interesting to understand how is reliable this technology, not only at the level of the PV cells level, but also at the PV modules level. So let's see the welding between cells. In the TOPCon, in the traditional PV modules is something like Z-type, so let's say it's not a straight line, and as you can see, the PV cells are very thin, but anyway, we have here a step, and it's something that can affect the reliability of the PV modules, in particular for the microcracks. For ABC cells, so all back contact cells, the soldering is in a line, so we have no this kind of problem. And furthermore, as the soldering is in a line, it's also possible to have a more strength soldering. So in this way, we have even a more resistant PV module. In case a microcrack occurs, something can happen also nowadays with strong wind or, for instance, with hail. We have a 20 busbar technology, so if microcracks occurs, it have an impact or a very little area of the cells. So let's see the characteristic now of the PV modules. For the residential, we have a PV modules in size 175 and 113, with and we are achieving the power of 470 watt peak with a module efficiency of 23.6%. And another important information, the power degradation. The first year is expected up to 1%, typical for N-type technology. And from the second year to the third is the maximum up to 0.35%. This means that after 30 years, we have roughly 89% of the nominal power. And is confirmed as per for all our PV modules, the minus 0.26% for every Celsius degree for the temperature coefficient on the Pmax. In the residential module, so we have all the advantages that we explained, so the partial shading optimization, the high temperature restriction, and also the microcrack resistance. And for the full black, of course, the stunning, beautiful full black by AIKO. For the CNI, we have the PV modules available as 32 meters 113 or also 2.28 and 113 with a power higher than 630, module efficiency 23.9, the same power degradation and temperature coefficient that we saw before, and also the same advantage in partial shading optimization, high temperature restriction, and microcrack resistance. For the utility, we have the same basic characteristic of the cells. The PV modules are now at least 640, but very, very soon we will have the 650. Remember, the utility is the only one modules available with by facility from us, and the size is 238 to 113. As usual, partial shading optimization, high temperature restriction, and microcrack resistance. If your application are on water bodies or closer to water bodies, we have also the waterproof package with an improved encapsulation and anti-corrosion frame. And very important also for the installer, a waterproof cap that help you to execute the installation near water or on water in safety. Thank you for your attention and see you soon at AIKO Online Training Series.